Hello and welcome to the Bearded Mathman's YouTube channel. In this video, what we're going to be talking about is using basic trigonometry to solve triangles. That means finding all the missing parts and pieces, all the sides and angles that are not listed, using trigonometry. So the tools of trig are basically what sine, cosine, tangent, and the inverse functions are. But you can also, for right triangles, you can also use complementary angles and the Pythagorean theorem. So what we're going to see is we're going to see how to put all of this information together in a nice fluid way to help you solve a triangle like this, to find the missing sides and the missing angle in a way that's repeatable, it's quick, seems fluid, and in a way that you can come up with some methods to check your answer by using different relationships. So if you want, it might be a good idea. You can look in the description. I will put a link where you can download a partially filled out reference sheet that you can use to help you solve right triangles. And then as you can print it off, and then as you're watching the video, you can take notes, and it might really help you so you have a good understanding of this sometimes really tricky lesson. All right, so let's jump into it here. I've got a triangle right here. I did a Google search for solving right triangles, and this is an image came up. I will put a link in the description below so you can go to the website where I found this diagram. But let's go ahead and jump into it. We're going to solve this triangle. That means we're going to find the angles x and y, and we're going to find this missing side over here. So one of the things that you really need to do is you have to be really good at making use of the information that has been provided, because that's a clue. That's a clue. So let's go ahead and start off with x. We don't have to necessarily start off with x. We can start off with the side. We can start off with y. We're just going to start off with x. So the information that's been provided, the way it relates to x is, well, this side is the hypotenuse and this side is the adjacent. And so if I look at SOHCAHTOA, I have an adjacent and I have a hypotenuse. Well, that's cosine, the CAH in SOHCAHTOA, right? That is, cosine is adjacent over hypotenuse. And so what you want to do is you want to start off by writing your generic formula. So cosine is adjacent over hypotenuse. Then you plug in your values, and then you go ahead and solve it. Now to solve this one right here, what we actually have to do is we have to use the inverse function. Now I made a big deal about this because sometimes it's easy to forget that when you're using trigonometry, that's actually a function. Cosine is a function. The input is an angle and the output is a ratio of sides. So if we want to solve for the angle, we have to use the inverse function. That takes that same ratio of sides as the input and spits out the angle as the output. So plug that into your calculator. You're going to get 36.9 degrees. That is rounded to 3 significant figures. You need to round appropriately based on the context or the instructions. Now, if possible, you don't want to use this value that we just found, this 36.9, to find y. Because if you made a mistake with this, well, this one's going to be wrong for sure. Now, of course, if you're running out of time on a test or something, then you just need to go ahead and subtract 90 minus 36.9 and get your answer. But if you have some time, then you should use the information provided as the clues to figure out this other angle. So that's what we're going to do right here. We're going to go ahead and use the clues to figure out y. So now the information they gave us is these two sides, and this is the hypotenuse, and 24 is the opposite. And so if you look at SOHCAHTOA, we have an opposite, we have a hypotenuse, that's sine. So start off with your formula, plug in your values. This is an inverse function because we need to find the value of the angle. We know the ratio of the sides. Plug it in, round it correctly. 53.1 degrees is what you got. Yeah? All right, now let's go ahead and see if we can figure out how to find the missing side. Now, we need to use the KISS method here. The KISS method, in case you don't know, it's a little rude. It's an acronym. It doesn't really mean to say anybody's stupid, but it's just an easy way to remember. Keep it simple, stupid. So in other words, use the simplest method possible to figure out this missing side, AB. And I would say that the easiest way to do that would not be using trigonometry at all, but instead using the Pythagorean theorem. So you just plug in your values. Once again, you don't want to do any calculation until you're absolutely done. You do all the work on paper, and then you do the calculation with the calculator, last step. This one, it wouldn't matter because it turns out to be a whole number, but if it was a decimal and you did the rounding on the calculator first, then you do more calculation with that rounding error, because every time you round it, it makes the number different, and those errors compound, and pretty soon you might have an answer that's very different than what it should be, and your only mistake is that you were using a calculator too much instead of doing the work on paper. So anyway, I'll get off the soapbox for that one. It's a big deal, though. It really upsets me because lots of students make those mistakes. They know what they're doing. They just are not being disciplined in writing on paper, and they're using a calculator too much. You get the wrong answer. So anyway, here's what we got, right? We went ahead and we used the information to find the clues. All right, so anyway, off my soapbox, for real this time. Now what we want to do, we have the entire triangle solved. So what we want to do is we want to use the different properties than we use to solve it to verify our answers. So for example, if the tangent of 53.1 degrees turns out to be opposite over adjacent, so if that turns out to be 24 over 18, if you plug that into a calculator and you find out that's true, then you're probably right. You could also do the same thing with the sine of 36.9. So if the sine opposite over hypotenuse is 18 over 20, if you plug this into the calculator and you get the same thing that this reduces to in a calculator, then you are probably 100% rock solid and you got the right answer. There's really nothing different with any of these examples. The clues they give you, the information they provide, is going to be related to the things you need to find differently, but really, it's all about identifying how that information that you're provided is a clue to what it is you need. Then you write down your generic formula, you plug in your values, and you solve it. You don't use your calculator to the last step, and then you round it. Then you have to be careful. You don't want to use your answers to find other answers if you can avoid it. Sometimes you have to, but if you can use the information they provided you, then you don't end up making a double mistake, and that's good. Always use the simplest method possible. So if you can use, the fact that in a 90-degree angle, that the two other angles that aren't the right triangle or aren't the right angle add up to 90 degrees, they're complementary, use that. Use the Pythagorean theorem instead of using tangent, for example. So keep it simple, stupid, right? And then do all of your work on paper, do the calculator last step, and then use the other properties to verify if you got it right. Just like we just did. Let's do one more example, right? Now, we're going to start off by trying to figure out how this information can be used. We have two sides. We have a right triangle. How can this information be used to find the two angles and the missing side? So I've got this right here. This is like a reference sheet of all the things we can use for a right triangle that we know so far. I'll put a link in the description. You can download it. Hopefully you already printed off the blank one. Don't copy and cheat. Just you can verify how you've done so far. Hopefully by this point you might already have the whole thing filled out. Anyway, we got to figure out how to use all of these tools in conjunction with the clues we've been given, and we're going to start off by finding the angle A. Now, the angle A, it's often in trigonometry, it's convention that we use lowercase letters for A, or for the angles, and we use the uppercase for the side. So lowercase a would be an angle, uppercase A would be a side, and that uppercase A would be the opposite. Now that's just kind of to introduce the idea to you so that maybe down the line you don't get super confused when you start seeing stuff like law of sines and law of cosines. It's a little thing that can derail people, but it's really not a huge deal. So lowercase letter, lowercase is convention in the United States anyway. Lowercase is usually the angle, uppercase is usually the side. That's different than the Pythagorean theorem, but let's move on. So for the angle A, we have two sides that we know. We have the adjacent side and we have the opposite side. Well, that's tangent. And because we have opposite and adjacent, but we need the angle, we're going to use arctangent. So all we got to do is start with our formula, plug your values in, round it to, I rounded this one to 3 significant figures, and boom, we're done. So I know that A is 70. Now, for the side B, for the angle B, the opposite of angle B would be side B. Once again, that would be capital B, but the value of that is 7. That's the thing we really need for now. So what we have is we have adjacent, we have opposite for angle B, and so opposite over adjacent, this time is going to be opposite is 7, adjacent is 19.2. Plug it into your calculator, you're going to get 20 degrees rounded to 3 significant figures. Now here, you should be able to realize that this side is much smaller than this side. 7 is much smaller than 19, so therefore the angle B should be a lot smaller than the angle A. If you're getting something that's counterintuitive, you might have made a mistake. So you need to be really, really careful with that. But here, this makes sense, and 70 plus 20 is 90. It's a right triangle. All that adds up. We're all good to go right there. Now, what about finding the other side? We're going to use the Pythagorean theorem. A squared plus b squared is c squared. Boom, we are done. So you just need some practice. I've got some problems here on the screen that you can just copy down, or you want to go to my website, beardedmathman.com. I will put a link in the description. You can go there. You can try these problems. You can print them off. You can try them there. You can read notes. You can watch other videos. Hey, if this has been helpful, I would very much appreciate it. Give me a thumbs up. Leave me a comment down below. How's this helped you? What are you still confused with? I'd be very happy to help you out. Give it a thumbs up. Subscribe if you like. Hope you have a great day.